Good morning, student. Welcome back to Atmiya Green School, Jhareshwar Bharuch. My name is Swati Sharma, and it's class 8 maths. Okay, Jai Swaminarayan. Now we have start revision because our fifth chapter is over. Okay, we have done in this session chapter first, that is rational number, linear equation in one variable, understanding quadrilateral, practical geometry, and now data handling. Okay, in our previous video we have talked about probability. Okay, so I hope you are completed in your notebook all this chapter. Now we have revised again. We have go for first chapter, that is our rational number. Now let's see what is rational number. Okay,
is. And the numbers we see here on the number line are called integers. On the right side of 0, we have positive integers, and on its left, we have negative integers. Integers we are familiar with, but what about numbers like these? 1 by 3, 5 by 6, or minus 7 by 12. Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers. But we need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form p by q. One number in the numerator and one in the denominator. But there are a few conditions we need to know. P and q should be integers. We can have only integers in place of p and q. And there is another important condition. Q should not be equal to 0. Why do we have the second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number. This value is undefined. So this is the basic definition of rational numbers. P by Q, where P and Q are integers and Q is not equal to 0. What is the difference between rational numbers and fractions? Are integers classified as rational numbers? What about 0? How do we plot such numbers on a number line? And how do we compare two rational numbers? For example, if you're asked to compare 1 and 5, you could easily say that 5 is greater of the 2. But what if you're asked to compare numbers like 6 by 7 and 13 by 15? How would you find out which one is greater? Don't worry to compare two rational numbers, 6 by 7 and 16 by 19. Up until now, we have seen a very logical way of comparing two rational numbers. If the denominators are the same, the rational number with the greater numerator is greater. And if the denominators are different, we make them same and then compare the numerators. Look at this example. The denominators are different. And using a calculator, we see that 6 by 7 approximately equals 0.8571 and 16 by 19 approximately equals 0.8421. Pretty close, I would say. Here, let's look at a simpler way to compare two rational numbers. Say we have two rational numbers, a by b and c by d. We assume that the denominators b and d are positive integers. To compare them, we just need to look at two products. First, the product of a and d, and second, the product of b and c. Product of these two and these two. But what do we do with these products? How do these two products help us compare the two rational numbers? There are three simple things we need to understand here. If AD, which is the product of A and D, is equal to BC, the product of B and C, then A by B will also be equal to C by D. If the product of these two integers is equal to the product of these two integers, then the two rational numbers will be equal. But what if AD is less than BC? Simple, then A by B will also be less than C by D. And if AD is greater than BC, then A by B is greater than C by D. That's how simple comparison of rational numbers is. If the products are equal, the rational numbers are equal. If this product is lesser than this one, then the first rational number is smaller. And if this product is greater than this one, then the first rational number is larger. Let's look at an example we saw a while back. We had to compare 6 by 7 and 16 by 19. So to compare these two rational numbers, all we need to do is compare the product of this integer with this one with the product of this integer with this one. AD in this case will be 6 times 19 and BC will be 7 times 16. 6 times 19 is 114 and 7 times 16 is 112. As we can see that 114 is greater than 112, we can be sure that 6 by 7 is greater than 16 by 19. That's how simple comparison of rational numbers is. But remember, the denominators have to be positive. So what if we were asked a question like this? Compare minus 6 by 7 and 16 by minus 19. Here, the denominator of the second rational number is negative. Does that mean we cannot compare these two rational numbers using this technique? Is negative. Does that mean we cannot compare these two rational numbers using this technique? Of course we can. We just write the second rational number differently. It's the same as asking us to compare minus 6 by 7 and minus 16 by 19. These two rational numbers have the same value. So keep in mind, if the denominators are positive, we can use the absolute value of a rational number. It's simple. All we have to do is ignore the sign of the number. Let's make two columns of the number and its absolute value. Let's consider the rational number 5. Remember, integers are rational numbers too. The absolute value of 5 is denoted like this. The number is written between two vertical lines. This number has no sign, so we just write it as 5. The absolute value of 5 is 5. What about minus 5? Its absolute value is written like this. This number has a sign. We just ignore the sign and write it as 5. The absolute value of minus 5 is 5. What is the absolute value of minus 6 by 11? It's written like this between two vertical lines. And what will it be equal to? Yes, we just ignore the sign and write it as 6 by 11. And what will be the absolute value of minus 6 by minus 11? Simple, we just ignore the signs. The absolute value of minus 6 by minus 11 is equal to 6 by 11. Many students think absolute value is changing the sign. But that's incorrect. We're just ignoring the sign. There is another way in which you can look at the absolute value. The absolute value will be the numerical value of the number without its sign. And observe the answers of the absolute value. They're always positive. So is this always true? What's the absolute value of 0? Well, it's 0 and it's not positive. I think we need to modify what we said earlier. We should correctly say that the absolute value of non-zero numbers is always positive. We represent rational numbers on a number line. A number line looks something like this. The positive integers are represented towards the right of 0 and the negative integers are represented to the left of 0. The numbers increase when we move towards the right and decrease when we move towards the left. It's easy to plot integers, but how do we plot numbers like 3 by 4? Before we understand how to plot this, we need to understand a very crucial point. Every integer except 0 has a corresponding integer. The integer 1 has minus 1 as its corresponding integer. The integer 2 has minus 2 as its corresponding integer. Similarly, every negative integer will have a corresponding positive integer. This tells us that if we somehow manage to plot 3 by 4, we can mark a point at the same distance on the left hand side of 0, which is minus 3 by 4. Now we can move on to the representation of rational numbers on a number line. To simplify things, we can classify the examples into two types. Ones in which the numerator is less than the denominator, and the other in which the numerator is greater than the denominator. Note that we see only the numerical value to compare the numerator and the denominator. For example, if we are plotting minus 9 by 5, we compare 9 and 5 and not minus 9 and 5. So minus 9 by 5 will come in the numerator greater than denominator category. We will look at two examples of the first category in the next video. The categories of plotting the rational numbers on the number line is when the numerators are less than the denominators. Let's try to plot 1 by 2 and minus 1 by 2 on the number line. First, we see how we can plot 1 by 2. The numerator 1 is less than the denominator 2. When the numerator is less than the denominator, the positive rational number will be between 0 and 1. So we draw the number line like this. The number 1 by 2 has to lie somewhere between 0 and 1. Now we divide the length between 0 and 1 into equal parts. How many equal parts is the question? The denominator tells us the number of equal parts. The denominator is 2, so we divide it into 2 equal parts. This line divides this region into 2 equal parts. But what does the numerator tell us? It tells us the number of parts starting from 0. The numerator is 1, and therefore we take one part from 0 and mark 1 by 2 here. We can use the same procedure to mark minus 1 by 2 on the left side of 0. Divide it into 2 parts and mark minus 1 by 2 one part away from 0. Just as integers had corresponding values, rational numbers too have corresponding values. In our example, minus 1 by 2 corresponds to 1 by 2. Let us look at another example where the numerator is less than the denominator. We have to plot 3 by 4 and minus 3 by 4. Let us plot 3 by 4 first. Since the numerator is less than the denominator, we know that the number will be between 0 and 1. So we draw the number line like this, with just 0 and 1 plotted. Remember, the denominator tells us the number of equal parts. Since the denominator is 4, we divide the length between 0 and 1 into 4 equal parts. Drawing these 3 lines gives us 4 equal parts. Now we move to the numerator. The numerator tells us the number of parts from the number 0. Since the numerator is 3, we move 3 equal parts from 0. 1, 2 and 3. So we mark 3 by 4 here. Now let us plot minus 3 by 4. Since 3 is less than 4 and the rational number is negative, we know that it will come between 0 and minus 1. We divide this length into 4 equal parts as the denominator is 4. And we mark minus 3 by 4 3 parts away from 0. That's it. We have plotted the points. But let me ask you a question. You have plotted the numbers 3 by 4 and minus 3 by 4. But do you know which numbers are plotted on these points? Here's your answer. Since this is one part, we mark 1 by 4 here. Since these are 2 parts, we mark 2 by 4 here. Similarly, we can plot minus 1 by 4 and minus 2 by 4 here. This was just for your understanding, and you don't need to mark all the points if you're asked to mark just 3 by 4 and minus 3 by 4. In the next video, we will try to plot rational numbers whose numerators are greater than their denominators. Let us plot 7 by 4 and minus 7 by 4. We try to plot 7 by 4 first. The first step in such kind of problems where the numerator is greater than the denominator is to convert it into a mixed fraction form. You would have learned this in your earlier classes, but let me quickly show you how. We only have to divide 7 by 4. We get the quotient as 1 and the remainder as 3. So we write the mixed fraction as quotient, remainder by divisor. This is the whole part and this is the fractional part. So we can write 7 by 4 as 1, 3 by 4. 1 is called the whole number part and 3 by 4 is called the proper fraction part. Each of the 3 numbers, 1, 3 and 4, tell us something about where 7 by 4 is plotted on the number line. The whole number part tells us the position of 7 by 4. So 1 tells us that the rational number 7 by 4 is between itself and the next whole number. The next whole number is 2. So we know that 7 by 4 is between 1 and 2. So we draw the number line accordingly with just 0, 1 and 2 marked. The denominator of the proper fraction part tells us the number of equal parts this segment is divided into. Since it is 4, we divide this segment into 4 parts. This segment between 1 and 2 is divided into 4 equal parts. The numerator of the proper fraction tells us the number of parts from the first whole number. So it is 3 parts away from 1. So we mark 7 by 4 here. What about minus 7 by 4? We can write minus 7 by 4 as minus 1 3 by 4. Now the number minus 1 tells us that minus 7 by 4 is between itself and the next number. Make note of the fact that the next number will be on the left hand side since minus 7 by 4 is a negative rational number. So the next number is minus 2. Now we can say that minus 7 by 4 is between minus 1 and minus 2. The denominator tells us the number of equal parts this length is divided into. So we divide it into 4 equal parts by marking 3 lines. The number 3 tells us the number of parts from the number minus 1. So leaving 3 parts from minus 1, we mark minus 7 by 4 here. With that, we are done with the topic of plotting positive and negative rational numbers.
Now let's see how many numbers between two rational numbers. Okay, let's see.
Let me ask you a question. How many integers exist between 5 and minus 5? We have 4 on the positive side, 0 and 4 on the negative side. 9 integers in all. Now let me draw a number line with rational numbers on it. In the center we have a 0. On the right hand side we have numbers 1 by 4, 2 by 4 and so on up to 5 by 4. On the left hand side we have numbers minus 1 by 4, minus 2 by 4 and so on up to minus 5 by 4. Now let me ask you a similar question. How many rational numbers exist between minus 5 by 4 and 5 by 4? If you count the numbers on the board, you will see 9 rational numbers. Is that the correct answer? No, the correct answer is infinite. There are two rational numbers, minus 5 by 4 and 5 by 4. The question is, how many rational numbers exist between these two numbers? Let's try to rewrite these two numbers a little differently. This number can be written as minus 50 by 40. We just multiply the numerator and the denominator by 10. And this one can be written as 50 by 40. We're not changing the values of the rational numbers, we just wrote them differently. Now think about it. How many rational numbers exist between these two rational numbers? Let's start writing them one by one. Minus 49 by 40, minus 48 by 40, and so on. Minus 1 by 40, 0, 1 by 40, and so on. 48 by 40, and 49 by 40. These were the numbers you could think of easily. These are the ones that lie between these two numbers. How many numbers are these? 49 negative numbers, 0, and 49 positive numbers. 99 numbers in all. Is that our answer? Are there just 99 rational numbers between minus 5 by 4 and 5 by 4? No, that is not true. We can write our original rational numbers as minus 500 by 400 and 500 by 400. Again, we wrote them differently. How many rational numbers exist between these two rational numbers? We can write them down as minus 499 by 400, minus 498 by 400, and so on. Minus 1 by 400, 0, 1 by 400, and on and on. 498 by 400 and 499 by 400. 499 numbers here, 0, and 499 numbers here. A total of 999 numbers. So now we can count 999 rational numbers between minus 5 by 4 and 5 by 4. What does this prove? It proves that if we increase the numerator and the denominator proportionally, the number of rational numbers in between that can be counted increase. And since there is no limit to how much the numerator and the denominator can be increased, there is no limit to the number of rational numbers in between the two rational numbers. This proves that there are infinite rational numbers in between two rational numbers. There is another way in which we can prove that there are infinite rational numbers between two rational numbers. 9. In the center we have 0. On the right hand side we have 1 by 4, 2 by 4 and 3 by 4. On the left hand side we have minus 1 by 4, minus 2 by 4 and minus 3 by 4 and so on. Say we want to find the number of rational numbers between minus 1 by 4 and 3 by 4. Before we try to find the number of rational numbers between them, let us try finding the average of these two numbers. To find the average, we add the two numbers and multiply them by half. So we can write the average as half multiplied by minus 1 by 4 plus 3 by 4. Since the denominators are the same in the bracket, we add the numerators over the denominator. It will equal half multiplied by minus 1 plus 3 divided by 4. That gives us half multiplied by 2 by 4. 2 cancels out from the numerator and the denominator and we get 1 by 4. If this is our number line and these two are our numbers, then 1 by 4 will lie here, exactly in between the two numbers. Now we have found one rational number between the two rational numbers. What are we trying to prove? We want to know how many rational numbers exist between two rational numbers. To find another number between these two numbers, we can find the average of these two numbers or maybe these two numbers. Say we choose the first two. That is, we find the average of minus 1 by 4 and 1 by 4. That will be half multiplied by sum of minus 1 by 4 and 1 by 4. This plus this is 0 and half multiplied by 0 is 0. The average of these two numbers will be marked here, exactly in between minus 1 by 4 and 1 by 4. Next, we can find the average of these two numbers or maybe these two numbers. What does this mean? It means that we can find averages endlessly, which proves that there lie infinite rational numbers between any two rational numbers.
Now let's see how to add two rational numbers. Okay?
We are trying to add two rational numbers here. It's definitely not as straightforward as adding two integers. Remember one golden rule. Whenever we compare, add or subtract rational numbers, we have to get the denominator same. For addition, the first step is to make the denominator same. In this example, we can see the denominators are already the same. In the second step, we just add the numerators over the denominator. The numerators are 4 and 9, and the denominator is 5. The sum will therefore equal 4 plus 9 divided by 5, which is 13 by 5. Many students tend to forget the third step, which is simplify the answer to its standard form. Can this number be reduced further? No, 13 by 5 is already in its standard form, and that makes it our final answer. The second example will give you a better idea. We want to add 5 by 8 and 7 by 12. The denominators are different in this case. So in the first step, we have to get the denominator same. The common denominator will be the least common multiple of both the denominators. It will be the LCM of 8 and 12. And that is 24. It is the smallest common multiple of both these numbers. Now let's see the procedure of getting both the denominators equal to 24. We want to write 5 by 8 plus 7 by 12 as some number upon 24 plus some number upon 24. We want the denominators of both the rational numbers equal to 24. To make the denominator of the first rational number equal to 24, we have to multiply the denominator 8 by 3. And to keep the rational number equivalent, we also have to multiply the numerator by 3. And 5 times 3 is equal to 15. The first rational number can be written as 15 by 24. For the second rational number, we have to multiply the denominator by 2 to make it 24. We also multiply the numerator by 2 to keep the value of the rational number unchanged. 7 times 2 is equal to 14. The second rational number can be written as 14 by 24. That's it. The first step is over. We made both the denominators same. The second and the third steps are simple. In the second step, we add the numerators over the denominator. We can write the sum as 15 plus 14 divided by 24. That equals 29 by 24. We just added the numerators over the common denominator. In the third step, we have to simplify it to standard form. 29 by 24 is already in its standard form and hence becomes our final answer. The sum of these two rational numbers equals 29 by 24.
So student, I think you have learned how to add two rational number if denominator is same and if the denominator is different. Okay, have a good day.